Hello, welcome to a coding challenge. This coding challenge is called the moth wings, butterfly wings coding challenge. I'm going to look at what would be a technique to generate algorithmically the wings of a butterfly or the wings of a moth. So this is inspired by a project by an artist named Katie Rose Pipkin. I will include links to information about their work in this video's description. Katie Rose makes a lot of kind of generative projects. They make Twitter bots, various other types of things. Good look on their website. So this is one of my favorite projects. It's called the Moth Generator. And what the Moth Generator does is it algorithmically tweets every once in a while a new moth. It gives it creates an image of the moth and it gives it a name. And you can scroll through the Moth Generator on Twitter. So what I want to look at is just there's no way I'm going to reach the level of sophistication and creativity that Katie Rose did with this project, but I want to at least look at what could possibly be a technique for designing algorithmically the wings of a moth so that they're different every single time. And let's see what we can do. So one thing in terms of making a wing pattern is symmetry. So whatever I do to create this algorithm on one side, all I need to do is flip and mirror that on the other side. And the technique that I think I will attempt is using polar coordinates. So I have several other videos where I've done this, and I'll link to a particular tutorial about polar coordinates in this video's description. But the idea here is I could use some very simple math to draw a shape that looked like this, calculate all these points, right? Because what I can do is I can think of every point as some angle, the Greek letter theta for an angle relative to the x-axis, and some distance out from the center, r. And I can determine this point's xy by saying x equals r times cosine of the angle, y equals r times sine of the angle. And I encourage you to look at the link to a video about that particular math function in more detail if you want to go and find out more. But right now I'm just going to use this formula. Now, what if instead of r, so theta is something that I'm just going to increase over time. What if r changes? For example, as I get down here, r becomes less. So I don't know what that's going to look like, but the r, that would kind of give an outward wing. So we could even just try that at first. But also, what if I were to use something like Perlin Noise, some randomness, to kind of offset these points to give it some other kind of pattern? So let's just give that a try and see what happens. Here I am. Okay, so now we want to begin programming. So I'm going to go over here, and I'm just going to do this in setup because I'm at this point I'm not going to have any animation. Oh, that'll be interesting to see. Maybe I could animate it in some way. So let's just first draw one side. So what I want to do is say var. I'm going to start with I'm going to do a for loop, and I'm going to use a for angle. I'm going to go from. This is a little bit tricky here because if I want to go from up here to down here, or from down here to up here, typically this would be 0, and this would be pi divided by 2, radians of 90 degrees. So I think what I want to do is go from negative pi divided by 2 to pi divided by 2. So let's do that. So I'm going to start at negative pi divided by 2. And I'm going to say a goes all the way up to pi divided by 2, and a increments by some arbitrary amount, 0.1. Then I'm going to say var x equals r times cosine of a, var y equals r times sine of a, and what is r going to be? Let's just make r equal to 100 for right now. Then what I want to do, and I guess what I'll do is I'm going to use the translate function to offset everything from the center. Translate 100, 100, and I probably should say width divided by 2 and height divided by 2. So everything is relative to the center. Because a canvas, right here, if this is the canvas, 0, 0 is actually by default here. So this thing that I'm drawing would be sort of half off and over here. So I want to translate 0, 0 to the center, so everything's relative to that. Then what I'm going to do is I'm just going to draw a point. I'm going to say stroke 255, and I'm going to say point x comma y, stroke weight 2, 4. So let's just see what I get. There we go. So I now have that particular path. That's pretty good. And I could do something where I say, you know, I don't know, start r equal to 100, and then I could say, you know, for every point, r minus minus. And you can see, I kind of know what that did. That's not really like a wing, but it's something. So it's almost like the other way around in a way that I want to do it. But the point is, I can start to vary r. Okay. Now, I want this to look more like a wing, so what I'm actually going to do is I'm going to say begin shape at the beginning and end shape. And then instead of drawing a point, I'm going to say vertex x, y. What that's going to do is going to make a continuous shape along that path. So you can see that. Now it has a fill. Maybe I don't want that. I don't know if I want the stroke weight to be 4. Let's take this stuff out here. I'm going to say stroke weight 1. And then I'm going to just to sort of see that fill, I'm going to give it sort of like an alpha E fill. And we can see, there we go. So there's my wing. Okay, we're done. Thank you very much. Good night. We got to make this a little bit better. So I got to think about other ways that I could vary what that R is over time. So one thing is Perlin Noise. This is a video that uses Perlin Noise. Oh, maybe you're watching this video and you have no idea what Perlin Noise is. So this video is now going to be inserted into the Perlin Noise playlist. So if you are wondering what Perlin Noise is, you can check this video's description and I will point you to a whole set of videos that describe it, the algorithm, what it is, how it works in more detail. But the way that you might understand it simply just for this video is it's an algorithm that allows you to pick random numbers. It is a random number generator, so to speak, but those random values are smoothed, meaning the number you pick is related to the previous number you picked. And so if I wanted to create some kind of smooth randomness like the borders of the edges of a butterfly or moth wing, this could perhaps be an algorithm that I could use. Okay, so let's think about how we could do that. So using Perlin Noise, I need to look at Perlin Noise values over an offset, a period of time or an offset along a dimension. So I'm going to create a variable called xoff for x offset. And this is, again, explained in my Perlin Noise videos a bit more. So you can pause, go watch those, and come back. I'll stop saying that. And I'm going to say x off plus equals 0.03 or 0.1. I'm just going to pick a value. And what I'm going to do is I'm going to say r equals, I'm going to get rid of this r minus minus thing, which was kind of unnecessary. I'm going to say r equals, so first I'm going to say var n equals noise of x off. So the noise function always gives me a value between 0 and 1, generally clustering around 0.5, but sometimes more, sometimes less, moving randomly, that sort of thing. So what I want to do now is say r equals map n, which has a range between 0 and 1, to, I'm just going to say, between 50 and 125. So let's look and see what I get. Now I'm getting somewhere. Look at this. I've kind of got this strange curvy-like thing. So let's play with this a little bit more. Let's look what happens when I increase the offset faster. I don't know if that's more or less like a moth wing. Also, like I'm incrementing by 0.1 for every angle, and it probably makes sense for me to kind of have a bit more resolution there. So now that's a little bit crazy, so I could go back and move a little bit slower through the Perlin Noise. Look at this. Almost right. I wish I had seeded this because that's just like sort of perfect to me. Look, I kind of have a weird sort of wing of a moth right now already. So there's more that I could do to this, but now one thing is I just want to at least flip it and see the other side. How do I do that? Well, incidentally, here's the wonderful thing. Perlin Noise is deterministic, meaning it's always going to return the same exact value for the same x offset. So there's no reason why I couldn't just go, and do this exact code again. And I'm sure I could do this without copy pasting it by like having an outer loop around the inner loop. But just for the sake of argument here, I'm going to just literally copy paste that code again, but change the range of angles. So what I want to do now is go from, not from negative pi over 2 to pi divided by 2. I want to go from negative pi over 2 to, I guess if I'm going this way, I want to go to negative 3 pi over 2. Is that right? I think that's right, because I'm continuing to go in the negative direction. So let's try that. I'm sure there might be another way to think about it that would be easier, but let's go from negative pi divided by 2 all the way to, as long as it's greater than, remember I'm going in a negative direction now, a negative 3 times pi divided by 2. And this is probably a ridiculous way to write these values out, but it's good, fine. And then a minus equals, and then exactly the same code. There we go. Now look, I have exactly mirrored it. Now I could make it just one continuous shape, which would make a lot of sense to do that. And I wasn't thoughtful about designing it in such a way that my incrementation value is exactly going to get me the whole way. So let's actually fix that, because that's sort of like, we want at least to like close at the bottom. So I'm going to say var d angle, like delta angle, dA for delta angle equals pi, right? Each side of the moth or the butterfly is pi divided by some amount of points that I want. I don't know what makes sense. 100 points? So that's like the incrementation. So I want to increment by dA, and then down here decrement by dA. And let's take a look. So this is with 100 points. It still didn't get all the way to the end. Do I need to say greater than or equal to, maybe? Less than or equal to, because I want to get one more point in there. Whoops. What did I mess up? Oops. Sorry. I'm still not getting this closed for some reason, so let me try a different tack. Actually, what I think I would like to do is go all the way to the bottom and then just keep going around, so I make it one continuous shape. So let's take out this end shape here and this begin shape. Now, this is not going to work because it's going to go all the way to the bottom. And actually, what I'm going to do is do this mapping just between 100 to keep it more on the screen. It goes all the way to the bottom, then it jumps up to the top, and then goes all the way around here. So what I actually need to do is when I get to the bottom is to keep going. So in that case, and I actually could condense this into just one loop, but I'm going to say, what I'm going to do is I'm going to start at pi divided by 2, and I'm actually going to go all the way to positive 3 pi divided by 2. I'm going to keep going at the bottom, right? And then a plus equals. But what I'm going to do is have offset not get reset, but I'm just going to say minus equals. So the noise values are going to be going up, 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 and then to mirror it, I'm just going to go back down, 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 all the way to the other side. I think this will work. Oops, I only got half of it. What did I miss here? A starts there. A is greater than 3. Oh, less than. Sorry, less than. And then going up. There we go. So now I have it as a perfect symmetrical shape. I can refresh it, and I can get a whole bunch of different. I don't know if I've really made moth wings. I've kind of made, and I really would need to think about how to make this more moth-like. Now, I think I have a kind of suspicion here that something that might be useful to try. Do you recall, I don't know why you would, that I recently made a video about polar roses math. So I'm going to look for this Wikipedia page. This is a particular algorithm to create these sort of petal-like formations on almost like a flower pattern. How could I apply this sort of rose formation into the moth pattern? Okay, so let's think about this. So if I were to do the polar rose literally, I might not use noise at all. And this is, by the way, very silly now that I have these two loops doing the same thing. I absolutely should condense that into one loop and just have the noise change at different parts of it. But I'm going to just leave it kind of this way for right now. I could say cosine of 2 times the angle, just to like try something, times 100. Just going to kind of put that polar rose code in there for a second. Whoops, and come back here. And look what I get. I get that kind of rose formation. But what if I combine that, and by the way, what if I combine that with, you can almost see, if you look at it diagonally, that looks like almost like a butterfly flapping its wings. What if I put the noise in with that? So instead of multiplying it times 100 as like R, what if I multiply the result of the noise function? And then I get something like this. Now, in the chat, I'm seeing the suggestion to do sine. So let's use sine instead of cosine. And there we go. And now it's on its side. But you can see that's kind of getting us somewhere. How could I rotate that? Or maybe it's, yeah, because it's symmetrical top to bottom now, the way that it's. So I could do, like, right now, just so we can like look at it differently, I could just say rotate by pi divided by 2. There we go. So look at this. And now I could kind of play with, I don't know what the number of points is or what this x. So this should really be dx just for the noise value. I'm going to just put the variable in here. And I'm going to put this in here. And now I'm going to refresh it. And I could try different values for different things, like move through the noise faster, move through the noise more slowly. Whoops. Move through the noise more slowly. I get something much more. Well, I could move more slowly, but have like, many more points. And now I get something like this. So there's a lot of possible ways I could start to explore this. Now, one thing I would like to show you before I go is what's really interesting about Perlin Noise is we can always add, let me just get it to some baseline, we can always add some sort of additional dimension. So right now I'm seeing the Perlin Noise values for one dimensional. The offset of the R, it's like, even though this is a two-dimensional drawing, I'm picking the noise values over a singular dimension. A way that I could, there's lots of interesting animations in color and other design ideas I could add to this, but what if I just wanted it to kind of like wiggle in some way? How can I change the Perlin noise values over time? Well, one way to do that, and there's a lot of different approaches I could take, but one way is to add the second dimension. So the noise values that I'm picking, the second dimension is actually frames of animation. So I get a set of noise values, then I get another similar set of noise values, then another similar set of noise values. So what I'm going to do here is I'm going to, and I defined R twice, somebody in the chat had mentioned that. I'm going to put all of this stuff in draw. So now I have a draw loop. Same program, but it's drawing it over and over again. I'm going to add a global variable called y_off. I'm going to set it equal to 0. And in my noise function, I'm going to say n equals x_off, y_off. That second dimension, I'm going to pick values. The second dimension being not a two-dimensional space. I've done that in other videos where the second dimension is actually like pixels in a two-dimensional space. I'm still asking for singular values to offset the R, but those values are going to change. The second dimension is time here. Then so every frame, I'm going, well, first let me add this in, plus 0.1, but I'm going to comment it out. So even though I added the second dimension, I'm getting just this. But now I can have that change over time. And you can see, look at what I've got here, this kind of crazy, weird animation of those values changing. So now I don't know what this is exactly, but this is my creation of butterfly wings, moth wings, animating using Perlin noise and some trigonometry in P5. And there we go. I kind of like this. I'm really excited and curious to see what you, the audience, the viewers, make of this. Hopefully you can make something more creative. You can think about color, you can think about design, you can add more features to it. Maybe you could actually try to see if you can make it so that the wings look like they're waving and flapping. Share with me what you do on Twitter, in the comments, all that sort of stuff. And just looking in the chat to see if I did anything terribly wrong. It wasn't on its side once I used sine. So I've got there's a lot of things you could add to this to make it more efficient, right? Condense those loops, figure out about the orientation better. But I'm going to leave the code as is and those things as exercises for you to do to make it better. Times x by the sine of frame count. Okay, wait a second. I'm just getting a comment from C. Manny in the chat. This video really should be over. So you could stop watching it. Times x by sine to the frame count. This here, sine of frame count. Again, I really hate that I'm doing all this twice. Sine of frame count. Now let's just do this. Whoa, okay. So frame count, how about times 0.01? So I really should have a counter. I could use y offset. You know what I could just do? I already have y offset. So I'm going to use y offset. There we go. Look at it flapping. It looks like it's ready. And maybe I want to do y because I wanted to sort of flap along its x-axis, I think. There we go. We've added something here. So I don't know what kind of crazy monstrosity I have, if that's really flapping, but you get the idea. We added a little quick extra feature there so you can see we've got flapping, moth, butterfly, wiggly, jiggly wing things in P5 with Perlin Noise, with trigonometry, and I can't wait to see what you make of it, okay? So I am going to leave this. So many more improvements I could make. I have to resist, and I'm going to leave this video. Thank you for watching. I will see you in a future coding challenge. Enjoy. Have a great, whatever it is, day, evening, morning, afternoon. Give somebody a hug. Smell the butterflies. That's not a thing. The roses, flowers. Anyway, appreciate the nature. It's a wonderful thing. Okay, goodbye.